Howdy folks, it's Mr. Ryan, and this is day 6 of Introduction to Statistics. And what we're going to do today is we're going to take what we learned in day 5 and we're going to extend it further into real life problem. Well, I say real life, they're actually going to be examples, but basically we're going to start doing word problems where we identify proportions of populations in real situations, okay, using the z-scores. Using the z-table to get probabilities, we're going to identify things like what is the probability that a car driving down the road is driving faster than a certain speed, and that could be interesting to a police officer or something. So I'm going to put together a couple examples and we'll get started. But first, we're going to review what we did on day 5. All right. Let's actually jump back to day 4, and I just want to remind you how to create a normal distribution. So let's say that we have a sample. We took a sample, and the mean of the sample is 29.8, and the standard deviation is 7.1. I want you to go ahead and construct a frequency distribution. Go ahead and pause the video, and then I'll do it, and we'll see if you got it right. All right, so the mean is 29.8, so we're going to put a 29.8 at the middle, right? Then the standard deviation is 7.1, so we're going to go up by 7.1 in all three of these. So 29.8 plus 7.1 is 36.9, okay? And then we're going to go up by another 7.1, and so this is going to become 44, and then another 7.1, and this becomes 51.1. Okay, now we're going to go to the negative side, and so if we subtract 7.1 from 29.8, we get 22.7, and then subtract 7.1 again, and we get 15.6, and then subtract 7.1 again, and we get 8.5. And so now what we have here, this is our normal distribution. So now let's move on to what we did on day 5, and that is let's identify the z-score of a particular observation in this population. So let's say that we want to know what the z-score for the observation let's pick a number maybe in here, something between 15 and 22. Let's say x equals 20. So the observation 20. So for example, let's say that these could be speeds of cars on the road. Let's say that 300 cars, a police officer measured the speeds of maybe 200 or 300 cars on the road, identified that the mean speed on that road is 29.8 with a standard deviation of 7.1. And so we want to know what z-score, how many standard deviations away from the mean is somebody who is driving 20 miles an hour. Now, 20 miles an hour is less than 29.8, so obviously it's going to be to the left. It's below the mean, so that's going to be a negative z-score. And our formula for a z calculation is z equals x minus x bar over s. So we take the observation, 20, subtract the mean, and then divide by the standard deviation. Probably going to need a calculator for this. All right, so I have a calculator. So let's go ahead and do our formula here. It's going to be 20. So our z-score here is going to be 20 minus 29.8 divided by 7.1. So 20 minus 29.8, enter, divided by 7.1 is negative 1.38. Negative 1.38. Okay? And what that means is that the observation 20 is negative 1.38 standard deviations to the left of the mean. This is negative 1 and this is negative 2, so negative 1.38 is probably right about here. So we could put a 20 there, and we could also say z is equal to negative 1.38. Okay? So that's one of the things that we did on day 5. And then the other thing that we did on day 5 was we learned how to identify proportions under the curve given any standard deviation using what we call a z-table, right? Or a standard normal cumulative probability table, okay? And so let's say that we had a z-score of negative 1.38, and we wanted to know what proportion, so this is negative 1.38, we want to know what proportion of observations are less than negative 1.38. And if you recall, so that would account for, if we shade this in, that would account, these are all of the observations that would be less than negative 1.38. This is the part of the curve that is below negative 1.38. And so, remember that in this table, all of the probabilities are less than probabilities. Therefore, whatever number we get in here is our answer. So we'll go to negative 1. Remember, it's broken up into two parts, the negative 1.3 and then the 8. So if we go to, on here, if we go to negative 1.3, which is right there, and then go to the 0.08 along the top and then come down here to the negative 1.3, we see 0.0838. 0, and that's a p-value. P equals 0.0838. Okay? Now I usually don't put the first 0 in, so it's p is equal to 0.0838. And that's the same thing as saying 8.38%, but we typically give our answers in the proportion, not in the percentage. And so that is how much of the probability is in this space right here. So 0.0838 of the population is less than a z-score of negative 1.38. Now what if we were to say, well, what proportion is larger? What about over here? What proportion is larger than negative 1.38? More than negative 1.38? Well, remember, what we said was this: if you want a more than proportion, you have to take the p-value from the table, 0.0838, and you have to subtract it from 1, because the whole curve is 1. It's one curve, right? And the whole thing is 1. If you include the whole thing, that's one thing. If you want to, and then you subtract the part that is less than negative 1.38, leaving what is more than negative 1.38, okay? The z-score of negative 1.38, okay? But this is a p-value. So 1 minus 0.0838 gives us 0.9162. 0.9162. So our p-value, our proportion that is more than negative 1.38 is 0.9162. And then the third kind that we did was we did a between. Let me erase some of this. There we go. We said, well, what if we want to know the proportion that is between, let's say we want to know what's between negative 1.12, a z-score, and between a z-score of 0.43. Well, what we would have to do is we would look up the p-value on both of these in the table. So let's do that. I hope you have your z-table in front of you. And we're going to look up negative 1.12, and we get 0.1314. I'm going to put an arrow, so p is equal to 0.1314. And then I need a p-value for this one, 0.43, 0.6664. And then what we do to find the, proportion between them is you subtract the smaller one from the larger one. So let me grab a calculator, and what I'm going to do is I'm going to take the larger p-value, 0.6664, and subtract the smaller p-value, 0.1314, and I get 0.535. So the proportion between these two z-scores is 0.535, and that's our answer. So that's a summary of what we did in day 5. So now what we're going to do is we're going to go one step further. We're going to learn how to identify What we're going to do now is we're going to take situations with real ideas, with real concepts, okay, like word problems, with real numbers. And then the only extra thing you're going to do today is you're going to take those numbers and then you're going to turn them into z-scores, then turn the z-scores into p-values, and then do the same thing that you did on day 5, okay? So I'm going to write an example up on the board, and we'll be back in just a few. All right, so here's the situation. We've got an employer, some business, gives a test to some job applicants, okay? So they have to take this test as a part of the application process to be hired by the business, okay? And those job applicants, after the tests were scored, the mean score is 163 with a standard deviation of 32, okay? So the first thing we want to do is we want to write that information down. So we're going to say that x bar is equal to 163 and the standard deviation is 32. So here's the question. What proportion of the applicants scored lower than 145? And so here's our procedure. Here's what we want to do to be able to answer this question. The first thing we need to do is we need to give or figure, let's say that, we need to figure or calculate the z-score for 145, okay? Now, if you're writing down general notes, just say the first step is to figure the z-score for the value that's being asked about, okay? So we got to figure the z-score for 145. Well, let's figure that out. The z-score formula is z equals the observation, which in this case is 145, minus the mean, which is 163, divided by the standard deviation, which is 32. So we're going to get a calculator here, and 163 minus 145 is 18. We're going to, excuse me, I did it backwards. It's 145 minus 163, which is negative 18, divided by 32 gives us negative 0.56. Now it's negative 0.5625, but we have to round this number. And since it's a 2, this is not going to go up. So our z-score in this case is negative 0.56. The second step is to find the p-value for the z-score. Okay? And you're going to do that in the z-table. You need the z-table to do that. So now, this is going to be turned into a p-value. So let's go into our z-table, and we're going to look up negative 0.56, negative 0.5, and then over to the column with the 6, gives us 0.2877, or 0.2877. And now you have to ask yourself, is this, so 3, for less than, you're done. That's the answer. And this is a less than question. Lower than 145. What proportion of applicants scored lower than 145? Well, the answer is P equals 0.2877. And that's our answer. We're done with that question. All right. Now let's alter this question a little bit. We're going to turn it into a more than question, and we're going to see that we have to add one more step. All right, so now we got the same question, same information, but now we're being asked, question 2 is, what proportion of the applicants scored higher than 200? So we're going to follow our procedure here. Okay, I'm going to change colors. The first thing says, figure the z-score for the values given. I changed the notes here for the values given. In this case, there's only one value given, okay, right? And that value is 200. So we need to find the z-score for 200. So z equals 200 minus 163 divided by 32. So let's grab a calculator, and we'll do 200 minus 163 divided by 32 is positive 1.16. So the z-score is 1.16. All right, we have a z-score. Now, find the p-value for that z-score. We got to go to the z-table, which is right here. And we're going to find 1.16. And I get 0.8770, or p equals 0.877. Okay, or you can put 8770 if you want to, but it's the same thing as 0.877. All right, so we have our p-value. But what's the problem? Is that all the values in here, all the p-values are less than p-values. But this question says scored higher than 200. So, let's see, we'll put a little mark here. All right, now for more than, if the question is asking more than, do 1 minus the p-value, okay? Do 1 minus the p-value. So we're going to do 1 minus 0.8770, and that's your answer. So we're going to do 1 minus 0.8770, and we get 0.123, and that's our final answer. So our answer is p is equal to 0.123. Okay, or you can write it as 0.1230, okay? And that is how you do a more than question. Just to review, in all of these questions, you're going to be given a mean and a standard deviation. Then you're going to be asked a question where they give you a number or two numbers. If they give you one number, it's either a more than or a less than question. And here's what you do. You just take that number, find out the z-score of that number, find the p-value that goes with that z-score in the z-table. If it's a less than question, that's your answer. If it's a more than question, you're going to take that p-value and subtract it from 1, and that's your answer. And the third kind of question is a between question, which I'll show you right now. All right, so now here's the third kind of question. All right, so we got the same situation. We got the employer given the test. We got the same mean, the same standard deviation. But now the question 3 is, what proportion of the applicants scored between 170 and 190? Between 170 and 190. Okay, so now it's a between question. So you see this first step, it says figure the z-score for the values given. And really it should be figure the z-scores for the values given. So because we were given two numbers, we have to calculate two z-scores. Okay, so let's calculate these two z-scores. Okay, we've got the number 170, we'll do that in purple. We've got the number 190, we'll do that in orange. So two separate z-scores here. So we're going to have the z-score for 170, we're going to do 170 minus the mean, 163, divided by 32. And then for 190, it'll be 190 minus 163 divided by 32. Okay? Let's grab a calculator and crunch some numbers. All right, let's see here. So we got 170 minus 163 is 7. Divided by 32 gives us 0.22. So our z-score for 170 is 0.22. Okay? Now, let's do the z-score for 190. We're going to do 190 minus 163, which gives us 27, divided by 32 gives us 0.84. 0.84. And now what we need is we need to turn both of those. Step 2 here, find the p-values for the z-scores, because there's two of them. So we've got to find two p-values in the table given two z-scores. So let's do the z-score for 170 gave us a z-score of 0.22, so let's look that up in the table. 0.22. That's going to be over here on the right-hand side. 0.22 is 0.5871. So a p-value of 0.5871. And now let's look up 0.84. 0.84 gives us 0.7995. 7995. And so now, this is not a less than question. It's not a more than question. It's a between question. So here's what we're going to say is for between subtract, you're going to subtract the larger p-value, so we'll say p sub L minus p sub S. That means the larger p-value minus the smaller p-value. And in this case, the larger p-value is 0.7995, and the smaller p-value is 0.5871. So now we just subtract. We'll do 0.7995 minus 0.5871, and we get 0.2124. And what that means is this. Let me show you, 0.2124. So we'll say P is equal to 0.2124. Now let me show you what that means on this normal distribution curve. Watch this. The z-score of 0.22, that's right about here, let's say. Let's go all the way up here. And the z-score 0.84, well, that's probably right about here. It goes up to about there. And so what this 0.2124 is, it is the region under the curve that is between those two z-scores, 0.22 and 0.84. And so the proportion in here is p equals 0.2124. And because the region of this graph has a proportion of 0.2124, that region represents all of the observations that fell between 170 and 190. Almost like it's basically a frequency distribution, as if it was a histogram with blocks. Okay? And so the way you answer a between question is you turn both of the numbers into a z-score, find the p-values for both z-scores, and then subtract the z-scores, and that gives you your answer. So in this particular case, about 21% of all the people that took that test scored between 170 and 190. Okay? All right, what we're going to do now is we're going to move on. We're going to take these same three situations, the less than, more than, and between, and we're going to ask questions of how many, and we're going to do that right now. Okay? All right, so what we're going to do now is we're going to answer questions that questions that ask how many. We don't always want to know just, hey, well, what proportion scored lower than 145? Sometimes we want to know precisely, well, how many of them scored below? How many are we talking about here? You know, was it 5 people? Was it 20 people? Was it 100 people? So in order to answer questions about how many, you have to have some kind of population. You got to know how many were in the population. And so you can see what I've written in here is, it says there were 520 applicants. So now that we know how many applicants there were, really all we have to do now is multiply our proportion answer, the ones we just did, how we got a p-value as an answer. Whatever your p-value is, you would just multiply it by 520, and that'll tell you how many applicants scored below, between, or above a particular score. So let's do this. Question 4 says, how many of the applicants scored less than 125? So the procedure is the same for finding a proportion, because we need a proportion to be able to multiply by the number of applicants. So we're going to do the exact same procedure here, but we're going to add one more step. And that one more step is just going to be multiply by the number in the population. So our first step is figure the z-score for the value given. In this case, we were given a value of 125. So we are going to figure the z-score for 125. So z is equal to, our formula is the number minus the mean. The number is 125. The mean is 163 divided by the standard deviation 32. So we got to do that in a calculator. So we're going to go 125 minus 163, enter, we get negative 38, divided by 32 gives us negative 1.19. So our z-score is negative 1.19, okay? Negative 1.19. Next step says find the p-value for that z-score in the z-table. Okay, so we're going to go to the z-table right here, and we're going to find negative 1.19, which is in the left column here. We're going to negative 1.1, and we're going to go all the way over the column at the end that has a 9 at the top, and our p-value is 0.1170. So this becomes p equals 0.1170. Now, in the questions we just did a few minutes ago, this is a less than question, right? It says how many applicants scored less than 125? So if this is a less than question, we're done. Well, we would be done. This is what we did a few minutes ago. This would be our answer, and we would move on to the next question. But now we're being asked a how many question. And how many questions tell us all we have to do, we'll put step 4 on here. We'll squeeze it in over here. Step 4, multiply the p-value that your answer is. It's either the p-value found in the table, or 1 minus the p-value, that's your new p-value, or it's the large p-value minus the small p-value, that's your new p-value. So your final p-value. So you got to multiply the final p-value times the given population. Times the given population. Meaning whatever number you were told was in the population. Times the given population. And that's the only extra step here. So multiply the p-value times the given population. So our p-value is 0.1170. So 0.1170, and we're going to multiply that by the population. It says there were 520 applicants, so we're going to multiply that by 520, and then we probably have to round the answer. You don't always have to round it, but a lot of times you do. So 0.1170 times 520, and sure enough, we got to round it. This is equal to 60.84, but there's no such thing as 0.84 people. We got to round this to the nearest whole number, which is 61. So what we would say is 61 applicants, or about 61 applicants scored less than 125. Okay? Now let's try a how many scored more than. Okay? All right, so now our question is, and this is question number 5, not question number 4. We just finished question number 4. Question number 5 is, how many applicants scored more than 250 points on the test? All right, well, we're just going to follow our procedure here. Step 1, figure the z-score for the value given. So we're going to figure the z-score for 250. Z is equal to 215 minus 163 divided by the standard deviation of 32. We need a calculator to do that. Well, we want a calculator to do that. 215 minus 163 divided by 32 gives us 1.625, which I'm going to round to 1.63. Okay, so there's our z-score, 1.63. The next step, let's see, find the p-value for the z-score in the z-table. So we're going to look up the p-value for 1.63. 1.6 is 0.9484. So p-value of 0.9484. Then it says for more than problems, do 1 minus p. So we want to do 1 minus 0.9484, and that'll be our true p-value, our final p-value. So we're going to do 1 minus 0.9484, and that gives us 0.0516. So P equals 0.0516. And now, our last step, multiply the final p-value times the given population. So we're going to multiply 0.0516 times the 520 applicants. So 0.0516 times 520, see what that equals, is 26.832. Now, that's not our answer, because there's no such thing as 0.832 people. We have to round this to the nearest whole number. So it's going to be rounded up to 27 applicants. So this is what we're saying, is that about 27 applicants, approximately 27 applicants, scored more than 215 on the test. This could be important to a business or to somebody who's looking to interview and hire, because they may say, okay, if only 27 applicants scored higher than a 215, those are our 27 highest scoring people. Those are the people that I want to interview, and you can send a letter to all the other people saying thank you for applying, but I'm sorry. Okay, so you can see how the statistics can actually be used to identify or to actually make business decisions, and they can be used for making other kinds of decisions too. Try one more kind of question, and we will be done with the lesson for day 6. Okay, the last kind of question we're going to learn today is how many between two numbers. So now our question is, well, how many of the applicants scored between 195 and 225? Okay, and we're going to do this the exact same way we did the last between problem. We're going to do it the same way we've done the other problems. We always start with figuring the z-scores of the numbers that we were given. We have two numbers, so we need two z-scores. And we'll do the same thing we did last time. We'll use purple for 195. We'll use orange for 225. All right, so the z-score for 195 is going to be 195 minus the mean, 163, divided by the standard deviation, 32. The z-score for 225 is going to be 225 minus the mean, 163, divided by the standard deviation, 32. So we're going to need a calculator for both of these, or we want a calculator. So 195 minus 163 is 32. Divided by 32 is 1. So we have a standard deviation. The z-score here is 1, or 1.00. I don't know if that helps you, but it's 1. But because you're looking it up in the table, you may want to have those zeros there. But really, it's just a standard deviation, a z-score of 1. So now let's try this one here. We got 225 minus 163 gives us 62. Divided by 32 is 1.94. 1.94. And so we have two z-scores now. And that's the first step. Now let's go to step 2. Find the p-values for those z-scores. We're going to need two p-values, right? So we're going to grab our table, and we're going to look up the p-value for a z-score of 1.00. That's somewhere right over here, 1.0. The first column ends with a 0, so it's 1.00 is 0.8413. So the p-value, and this is going to be the smaller p-value, is 0.8413. I know that this p-value is the smaller one because it's the smaller number. Smaller numbers always have smaller z-scores and p-values than larger numbers. Okay? All right, so now let's look up 1.94. 1.9, and then we're going to go over to the fifth column, which has a 4 at the top of it. 1.94 is 0.9738. 0.9738, so the larger p-value, I forgot it already, 9738. 0.9738, okay? All right, so now it says for less than, nope, that's not this one. For more than, that's not this question. This question is a between question. Okay, for between, subtract larger p-value minus smaller p-value. So we got to do larger minus smaller. So we got to do 0.9738 minus 0.8413. Let's go ahead and grab a calculator. 0.9738 minus 0.8413 gives us 0.1325. 0.1325. So that is our between proportion. But we're not done yet because the question is not asking what proportion is between 195 and 225. It's saying how many applicants between 195 and 225. So we need to do our last step here, step 4, multiply the p-value that we just got, the final p-value, times the given population. So we're going to take our 0.1325, we're going to multiply it by the population. There were 520 applicants, 520, and we're going to go 0.1325 times 520, and that gives us 68.9. 68.9. Now, we can't say that 68.9 applicants. We need to round it. So we're going to round to the nearest whole number. So the 9 tells us to go up. So we're going to say 69 applicants. 69 applicants scored between a 195 and a 225. Okay? And so sometimes that can actually help you know certain things about the test or about the applicants. You can know whether you got an average batch of applicants, or it can help you understand whether you got a particularly high-performing batch of applicants or a particular low-performing batch of applicants. Okay, but this is it. The worksheet that I have for you has, I believe, where's that worksheet? Oh, here it is. The worksheet that I have for you has 6 problems like this with 3 parts each on the front, and then 6 problems with 3 parts each on the back. The front of the worksheet is just proportion questions. The back of the sheet is are questions that ask the question, how many? Okay? And that's all I have for you, and I'll look forward to seeing you in day 7, where we can go one step further, and we'll take this whole process and we're going to move backwards. Okay? So have a great day.